Carbon monoxide by Karen Bogren, Merrickson, and Nicolas Yosa. Carbon monoxide is a colorless, odorless, or tasteless gas. Its molecule is comprised of a carbon atom and an oxygen atom, and it is bonded with a triple bond. The molecule is formed in incomplete combustions of carbon-containing compounds like natural gas, kerosene, gasoline, oil, propane, coal, and wood. An incomplete combustion happens when the combustion reaction is provided with insufficient oxygen, when the flame temperature is cooled before the reaction is completed, and the time to burn is insufficient. An example is the combustion of propane gas. The equation for the complete combustion is propane reacting with oxygen to produce carbon dioxide and water.
So the enthalpy of combustion for this reaction is calculated using the enthalpy of formation for each substance. Here's the enthalpy of reaction for the combustion of propane. The enthalpy of combustion is negative 2219.8 kilojoules, meaning that it is exothermic.
So here is the equation for the incomplete combustion of propane, where propane reacts with oxygen to produce carbon dioxide, carbon monoxide, and water.
Same as the first equation, the enthalpy of combustion can be calculated using the enthalpy values listed in the table. For the complete combustion, the enthalpy is negative. For the incomplete combustion, the enthalpy is negative 2019.8 kilojoules, meaning that it's also exothermic.
Some causes of carbon monoxide include man-made sources like vehicle emissions and burning of agriculture. Natural sources include volcanoes and forest fires, which release carbon monoxide into the atmosphere through ash and smoke, which can affect the well-being of humans, causing headaches, dizziness, vomiting, and nausea if breathed in. And if carbon monoxide levels are high enough, you may become unconscious or die. Centers of Disease Control and Prevention also state that exposure to moderate and high levels of CO over long periods of time has also been linked with increased risk of heart disease. Plants, however, don't get affected since it is rapidly oxidized to form carbon dioxide, which is used for photosynthesis. Carbon monoxide is a pollutant that can persist in the atmosphere for about a month and can be transported to great distances. As seen in the image, there was a forest fire in California, and the release of carbon monoxide was distributed across many states. Although carbon monoxide is only a weak greenhouse gas, its influence on climate goes beyond its own direct effects. Its presence affects concentrations of other greenhouse gases, including methane, tropospheric ozone, and carbon dioxide. It thus plays a role in both air pollution and climate change, and is therefore regulated to many parts of the world. This means that land and sea temperature will increase, changing ecosystems, increasing storm activity, and causing other extreme weather events.
So the presence of CO affects the climate change indirectly. It affects the abundance of greenhouse gases such as methane and carbon dioxide. We can see as the carbon dioxide concentration increases, the global temperature increases. The energy that the planet absorbs from the sun is then released back to space. When the energy is released, it must travel through the atmosphere. Each time the atmosphere contains more CO molecules, it is harder for the energy to get to space. Since the energy is not released to space due to CO molecules, it is kept in the world's atmosphere. Therefore, the internal energy, kinetic plus potential energy, stays inside the Earth. Since energy is heat, the global temperature increases and creates global warming. So how does this happen? The CO molecules absorb the radiation released to space and is re-radiated back to Earth. This provides more energy to Earth and more heat is created. When the work done by the system, the W in the equation of delta U equals delta Q minus delta W will be positive. In this case, the work is done by the system. Then the work done is added to the energy, and it will cause an increase in the temperature.
In the body, carbon monoxide is poisonous. Hemoglobin is a protein found in the blood with 4 heme groups, each containing 1 iron atom. Oxygen is picked up by the hemoglobin by loosely binding to the iron atom. Then, when there is a slight difference in the concentration of oxygen, the oxygen is released. Carbon monoxide is poisonous because it competes with oxygen in its binding site. Since it has a greater affinity to iron, it more easily replaces the oxygen atom. When it binds onto the iron atom, oxygen can no longer bind to the site, so the hemoglobin carries less oxygen. The oxygen that later binds to the same site will have stronger bonds with the iron, making it harder to release itself to the cell in need of oxygen. Without enough oxygen being delivered, the cells are unable to go through their metabolic processes like aerobic cellular respiration.
So overall, the CO is greenhouse gas produced from incomplete combustions that affects the atmospheric temperatures and is poisonous to human bodies.